Imagine a world hidden beneath the waves, a world of vibrant coral reefs teeming with life. Imagine bizarre creatures, unseen by most, gliding through the deep. This is our ocean, a vast and mysterious realm covering most of our planet. For centuries, the ocean has captivated our imaginations. It's a source of food, a means of travel, and a place of endless wonder. Yet we've explored only a tiny fraction of its depths. The ocean is a mystery waiting to be unraveled. It holds the secrets to our planet's past and the key to its future. But exploring this underwater world is no easy feat. The crushing pressure, the lack of light, and the vast distances make it a challenging environment. However, humans have never been deterred by a challenge. The desire to explore, to understand, to push the boundaries of knowledge has driven us to develop incredible technologies. From simple diving bells to sophisticated submersibles, we've created tools to venture deeper and see further into this blue abyss. Join us now on a journey into the deep. Let's dive into the history of underwater exploration, celebrate its triumphs, and look ahead to the future of uncovering the ocean's secrets. Our fascination with the underwater world is not new. For centuries, people have been diving using simple breath-hold techniques to gather food and resources. Ancient civilizations like the Greeks and Romans were skilled free divers. They used rudimentary diving bells, air-filled containers to extend their time underwater. These early attempts were limited. The depths they could reach and the time they could spend submerged were restricted. Yet, they represent the first steps in our quest to explore the underwater realm. It was a slow and cautious exploration driven by necessity and curiosity. Marine historian as S1 fast forward to the 19th century, and we see the development of the first true diving suits. These early suits, bulky and cumbersome, allowed divers to stay underwater longer and venture deeper. They paved the way for more ambitious explorations like underwater salvage operations and scientific studies. One name stands out in the history of underwater exploration: Jacques Cousteau. A pioneer in marine conservation and filmmaking, Cousteau co-developed the Aqua Lung, the first commercially successful self-contained underwater breathing apparatus, or scuba. This invention revolutionized diving, making the underwater world accessible to many. Cousteau's documentaries like The Silent World brought the beauty and wonder of the ocean to millions. His work ignited a passion for underwater exploration and highlighted the importance of protecting our oceans. The evolution of diving suits is a fascinating story of human ingenuity, showcasing how humans have continually pushed the boundaries of underwater exploration. Early suits made of canvas and leather were heavy and inflexible, severely limiting movement and depth. These early designs were cumbersome, making it difficult for divers to maneuver underwater. The invention of vulcanized rubber in the mid-1800s marked a significant advancement. These new suits were more flexible and watertight, allowing divers to stay underwater for longer periods. However, despite these improvements, these suits still relied on surface-supplied air, connecting divers to a ship or a platform above. This connection was both a lifeline and a limitation. This tethering limited their range and freedom of movement, restricting the areas they could explore and the tasks they could perform. Oceanographer as S2. The development of scuba gear in the 1940s was a revolutionary game-changer in the world of diving. Divers were no longer tethered to the surface, granting them unprecedented freedom. They could move freely, exploring the underwater world with newfound agility and independence, opening up new possibilities for underwater exploration. Modern diving suits are marvels of engineering, incorporating advanced technology and materials. They use advanced materials like neoprene and dry suits to keep divers warm and dry in cold water, ensuring comfort and safety in various underwater environments. Sophisticated regulators ensure a steady supply of air at varying depths, adapting to the changing pressures of the underwater world. Underwater communication systems now allow divers to talk to each other and to the surface, enhancing coordination and safety during dives. These technological advancements have made diving safer and more accessible, allowing more people to experience the wonders of the underwater world. Today, millions of people enjoy recreational diving, exploring coral reefs, shipwrecks, and underwater caves. The beauty and diversity of these underwater landscapes attract divers from all over the world. Scientific divers use these advancements to study marine life, collect samples, and monitor the health of our oceans. Their work is crucial for understanding and protecting marine ecosystems. But even with these advancements, diving has its limitations. Depth, time underwater, and the effects of pressure restrict how far and how long humans can explore. The deeper divers go, the more they are affected by pressure, which can have serious physiological effects. This is a significant challenge for deep-sea exploration. To venture deeper and further, we need more advanced technologies. Innovations such as submersibles and remotely operated vehicles are paving the way for future exploration, allowing us to reach depths previously thought impossible. To reach the deepest parts of the ocean, we need vessels capable of withstanding immense pressure. The ocean depths are a hostile environment, with crushing pressures that can easily destroy conventional vessels. This is where submersibles come into play. These specialized underwater vehicles are designed to endure the extreme conditions found in the deep sea. These underwater vehicles, designed to operate at great depths, have allowed us to explore the ocean's hidden trenches and abyssal plains. They open up a world that was once completely inaccessible to humans.
The first submersibles, like the bathysphere and the bathyscaphe, were pioneering feats of engineering. These early designs laid the groundwork for modern deep-sea exploration. They were essentially underwater balloons, using ballast and gasoline to control their descent and ascent. This simple yet effective method allowed them to reach unprecedented depths. In 1960, Jacques Piccard and Don Walsh made history by reaching the Challenger Deep in the Mariana Trench, the deepest known point on Earth in the bathyscaphe Trieste. Their journey marked a significant milestone in human exploration.
Modern submersibles are far more advanced. They incorporate cutting-edge technology to enhance their capabilities and ensure the safety of their missions. They are equipped with powerful lights, high-definition cameras, and robotic arms for collecting samples. These tools allow scientists to gather valuable data and specimens from the ocean floor. Some submersibles, like the famous Alvin, can carry scientists, allowing for direct observation and research in the deep sea. This hands-on approach provides insights that remote instruments alone cannot offer.
These deep-diving vehicles have revolutionized our understanding of the ocean. They have expanded our knowledge of marine biology, geology, and chemistry. They've revealed unique ecosystems, strange and wonderful creatures, and geological formations that help us understand our planet's history. Each dive uncovers new mysteries and adds to our understanding of the deep sea. They've also played a crucial role in exploring shipwrecks, like the Titanic, resting thousands of meters below the surface. These explorations provide historical insights and help preserve maritime heritage.
However, even with their advanced capabilities, manned submersibles are expensive to operate and pose inherent risks to the crew. The challenges of deep-sea diving require meticulous planning and robust safety measures. This has led to the development of remotely operated vehicles, or ROVs, and autonomous underwater vehicles, or AUVs, which are changing the face of underwater exploration. These unmanned systems can reach great depths without risking human lives, making them invaluable tools for modern oceanography. ROVs and AUVs represent the cutting edge of underwater exploration. These remarkable machines have revolutionized the way we study and interact with the ocean's depths. These unmanned vehicles allow us to explore the ocean's depths without putting human lives at risk. By eliminating the need for human divers in dangerous and extreme environments, we can push the boundaries of our knowledge further than ever before. They are our eyes in the deep, sending back data and images that would be impossible to obtain otherwise. The high-resolution cameras and advanced sensors on these vehicles provide us with unprecedented views of underwater landscapes and marine life.
ROVs are tethered to a surface vessel or a platform via a cable that transmits power and data. This connection ensures a continuous flow of information and control, allowing for extended missions and detailed exploration. They are controlled remotely by pilots who use cameras and sensors to navigate and manipulate the vehicle's robotic arms. These skilled operators can perform delicate tasks, such as collecting samples or repairing underwater structures with precision. This allows for precise control and real-time observation of the underwater environment. The ability to make immediate adjustments based on live feedback is crucial for successful missions.
AUVs, on the other hand, operate autonomously. These vehicles are designed to carry out pre-programmed missions without direct human control, making them highly efficient for long-duration tasks. They are pre-programmed with a mission and can navigate and collect data without human intervention. This autonomy allows them to cover vast areas and gather extensive data sets that would be challenging to obtain manually. This makes them ideal for surveying large areas, mapping the seabed, and conducting research in remote and challenging environments. Their ability to operate independently for extended periods is a game changer for oceanographic studies.
Both ROVs and AUVs are equipped with a suite of sensors and instruments. These tools enable them to perform a wide range of scientific and industrial tasks with high accuracy. They can measure water temperature, salinity, and currents. These measurements are essential for understanding oceanographic processes and monitoring environmental changes. They can collect water samples, map the seafloor, and even create three-dimensional models of underwater structures. These capabilities are invaluable for studying marine geology and biology. They are invaluable tools for scientists, researchers, and industries like oil and gas exploration. Their ability to operate in extreme conditions makes them indispensable for tasks such as pipeline inspections and resource assessments.
The use of ROVs and AUVs is rapidly expanding. As we continue to develop and refine these technologies, their applications will only grow, opening new frontiers in marine science and industry. They are helping us to discover new species, study the impacts of climate change on marine ecosystems, and explore the potential for sustainable resource extraction from the ocean. These discoveries are crucial for preserving marine biodiversity and managing ocean resources responsibly. As technology advances, these underwater robots will play an even more significant role in our quest to understand and protect our oceans. The future of ocean exploration is bright, with ROVs and AUVs leading the way into the unknown depths.